This is section 2.5, types of solutions of linear equations. Our objective today is to identify whether a linear equation in one variable has one, infinitely many, or no solutions. A linear equation in one variable is quite simply the type of equation we've been solving. We're going to have one variable, and there's going to be no powers other than a 1 on your variable. So our types of solutions. You're going to want to look at this part right here. If you get something like A equals B, that'll be like 3 equals 7. Well, 3 never equals 7, so there are no solutions. If you get something like X equals A, that's where you get like X equals 4. That's one solution. We found that solution, that's our 1. And infinitely many, that's when you get like 3 equals 3. 3 always equals 3, so every value that I plug in for X will work for that equation. So let's figure this out. For letter A, I just start to solve. If 2x minus 4 equals negative x minus 1. To start, let's add our x over. We get 3x minus 4 equals negative 1. Add the 4. We get 3x equals 3. Divide by 3. X equals 1. We got x equals a number. That is one solution. These are the most common type of problem. Let's look at letter B. 2x minus 4 equals 2 times x minus 2. We're going to start by simplifying the right-hand side and distributing. The left stays 2x minus 4. The right becomes 2x minus 4. Let's get all of our variables on the same side, so we subtract our 2x off. We get negative 4 equals negative 4. Well, when does negative 4 equal negative 4? All the time. Our solution is infinitely many solutions. And then let's look at letter C. 2x minus 4 equals 2 times x plus 1. We're going to start by distributing on the right here. So the left stays 2x minus 4. The right becomes 2x plus 2. To start to solve, I subtract 2x off of both sides. I get negative 4 equals 2. Well, when does negative 4 equal 2? Never. This one has no solution. There's no value that will make this work. So at this point, you might realize a couple shortcuts that we could use. In one, let's look at no solution first. You'll notice in our simplified spot here, right here after we simplified first, our variables have the same coefficient. They both have that 2. But they have different constants. There's a minus 4 and a plus 2. That's how we know. That's our shortcut for no solution, if they have the same coefficient and different constants. For our infinitely many solutions, in our simplified version here, we notice that they have the same coefficient again, but they also have the same constant. As soon as you see that, you can use our shortcut and say infinitely many solutions. In our one solution one, you'll notice our coefficients are 2 and negative 1. Those are different coefficients. That tells me right off the bat that they're going to be one solution. So you can either go the long way or you can use the shortcuts. So try these 4. Decide whether they have one solution, infinitely many, or no solutions. Well, for letter A, the first thing we should do is distribute the right-hand side, and we'll get 5x plus 8 equals 5x plus 15. In this case, we have the same coefficient and different constants, so there is no solution. In letter B, we don't need to distribute anything. We look right at our coefficients, a 5 and a 9. They're different. That means there is one solution. For C, we want to distribute the right-hand side, so we'll get 6x plus 12 equals 6x plus 12. They're exactly the same. We have the same coefficient, same constant. That is infinitely many solutions. And then for letter D, let's look at our coefficients by changing it into a sum. So we have 7x plus negative 11 equals 11 plus negative 7x. Are these the same coefficient? 7 and negative 7? No, they're not, which means we have one solution. All right, let's look at a word problem. You want to take 10 lessons at a swim club. You can pay a membership fee of $20 plus a fee per lesson. You can also decide not to pay a membership fee. In that case, the fee per lesson is $3 more. Is there any lesson fee for which the two plans cost the same? Let's look at if you're a member. If you're a member, you're going to pay $20, plus I'm going to pay for every lesson, I don't know how much. I'm taking 10 lessons, that's 10x. I want to know if that's ever going to equal 10 lessons, but I'm going to pay that lesson fee plus $3 for each lesson. We'll distribute on the right-hand side, so I get 20 plus 10x equals 10x plus 30. At this point, I can answer the problem. I have the same coefficient, but a different constant. There is no solution. That's not the answer to my question, though. It says, is there any lesson fee? No, there's not any lesson fee. They'll be the same. All right, admission to the museum is $8 for students and $16 for adults. Yesterday, twice as many students as adults came to the museum. The total admissions paid by students and the total admissions paid by adults were equal. Can you find the number of adults that came to the museum yesterday? So let's look. $8 for students, $16 for adults. Twice as many students as adults came. So let's say there's A adults that came. That means there's 2A students that came. Is there any amount that these are equal? Well, we simplify their left-hand side. We get 16A equals 16A. Well, yeah, any number of adults and students. Can you find the number? No, we cannot, because there's infinitely many solutions. Your assignment is out of the textbook.